right, and 1 from beginning. Duplicate. All right, chapter 10 area. Keep in mind, and this is very important for this unit, when calculating area with the exception of circles, the dimensions you use are perpendicular. The dimensions you used are perpendicular, which means you should be looking for a right angle symbol. The microphone's on, I'm not moving. All right, hopefully everybody knows. Theorem 10.1, the area of a rectangle is the product of its base and height. The area of a rectangle is the product of its base and height. All right, now, you may know the formula already, but let's talk about parallelogram. All right, so up top we have ourselves a rectangle, base times height. If we take any line like we did here and draw it in the middle, and then cut the figure right up, which means we take this portion and move it over here. All right, so now this is gone. Now this is gone. That's all gone. And move that over. Have we changed the amount of space it takes up? Yeah. So the area would be exactly the same. So the area of parallelogram is still base times height. Where the height makes what kind of angle? Right angle. All right. So that's why a parallelogram and a rectangle are the same. You don't want that. That's Monday's lesson. The area of a parallelogram is the product of its base and corresponding height. All right. Good. All right. So, a note on this. The height is the length of an altitude. The height is the length of an altitude, which is a segment perpendicular to the line containing the base. All right. All right. So basically, with that drawing, combining the diagrams, all right, you can find the area using A times B or C times D. You can find the area using A times B or C times D. As a result, we're allowed to say AB equals CD. As a result, we're allowed to say AB is equal to CD. And then the last figure in 10.1, if at first you don't succeed, try triangle again. In other words, a triangle. Okay? And this is where our friend the triangle comes from. If I create, what are you doing, dude? All right. Triangle interior, all right? So we got a pretty green. If I rotate that 180 degrees, if I rotate that 180 degrees and change the color just because I like changing the color, I have that on the outside, correct? If I do the same thing on the other side, do the same thing on the other side. Triangle interior, display, color. All right. And I do the same thing, rotate it 180 degrees. Make that a pretty color. Or non-pretty color, depending upon your perspective. What do you notice? First off, what shape's formed? A rectangle. So the original triangle makes up what fraction of the rectangle? Half. Area of rectangle is base times height. So if you incorporate a half, how do you get an area of triangle? 1/2 base times. All right. So the area of a triangle is 1/2 the product of its base and the corresponding height. Oops. The area of a triangle is 1/2 the product of a base and the corresponding height. Please, oh please, do not include extensions of sides when calculating area of the dashed lines. What I mean by that is this. How these are different. That is a dimension. That is the height. I know that because it is a distance off to itself. This dashed line is an extension of B. Does everybody understand what I mean by that? As a result, you never use that when calculating area. All right? If we're talking about irregular figures, we divide into triangles and parallelograms. If we talk about the coordinate plane, we're going to use square units as your label. We're going to draw lines, find intersections, and calculate. And since yesterday people had an issue with that being blank, we threw sponge. Good. All right. Now, the top of the next page didn't copy very well, but here's the idea. All right, and this is right out of your book. So if you want to look at N1 in your book, that's where it comes from. We originally did this last year at the beginning of the pandemic. As a result, it was easier to see because kids had their book. All right, so if you have a irregular figure for the time being, this pentagon, you can divide it into two shapes that we know how to do. So, for example, the bottom portion is a square, right? 6 by 6 makes its area 36. The top portion is a triangle. You can assume these are congruent if they lie on top of each other. So if that's 6, that's 6. 6 times 8 is 48. The difference with a triangle is you got to divide by 2. Anybody know what half of 48 is? 24. Your last step would be add the areas. 36 plus 24 gives your total areas. Okay? All good? All right. In terms of coordinate geometry. Stop talking. It's your off period. Go take a nap. Chapter 10-1 notes. All right. So this is the idea. We're looking at that figure. And we're looking at that figure. It's just counting. So if you're going from D to C, that is a base. 1, 2, 3, 4, 5. So that, ladies and gentlemen, has a length of 5. All right, good with that idea. Now the height. You have to realize, ladies and gentlemen, life is made so much easier if we use vertical and horizontal line segments, because then we do not need to use distance formula. All right? That is why we're using AC and CD and not BC, and it's perpendicular. Does that make sense to everybody? Good. All right? So if I make that nice and thick, that's the height. Even though it goes outside, it's still the height. Got me? So now all I'm going to do is count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Got me? So you're looking for horizontal and vertical line segments. What's 5 times 12? So what's the area of that parallelogram? 60, and you just use square units or units squared as your label. Everybody good thus far? Any issues? Subscriptions, memberships? Tomorrow, the gang, Monday, the gang's all here except for the gang that's not here. Yep, okay. So let's take a look then at some practice problems, shall we? So let's make sure everybody at home can see. All right. So, what do you think is the number one mistake students would do wrong in number 2? What do you think is the number one thing? Use the 5. Why are we not going to use the 5? Because it doesn't make what kind of angle? Right angle. So instead, what are we going to use? 7 times 4, which would be 28. All right, number 4, there's the 15. What's its height? The 6 or the 6.5? 6. 15 times 6 is 90. All right, 15 times 6 is 90. All right, notice we don't use that. No. We don't use that. No. All right, so do me a favor to start off number 7, just find its area. You do not need to find H, you just need to find its area. Yep. 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 Oh, here, 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 here. All right. So if I do the area, I would do 5 times 8.4 gives you an area of 42 units squared. Everybody good with that? Okay. But if I'm going to get the area, that times that should also work, correct? Yeah, well, opposite sides of a parallelogram are equal. So if that side is 6, this side is also what? 6. So 6h would give me the same area, which is 42. How do I get rid of multiplication by 6? Divide by 6, and h equals 7. All right, all good? All right, area of a triangle is 36 meters squared, and the height is 9 meters. Find the length of the corresponding base. Please, oh please, don't forget, area of a triangle involves 1/2 base times height. All right, 1/2. The base is unknown. The height is 9. And that is equal to 36. All right. Now, this is all multiplication, which means we can do it in any order we want, correct? Which means we can undo it in any order we want. In other words, can I divide both sides by 9? Yep. And does 9 go into 36? Yep. So 1/2 b is 4. How do I get rid of a 1/2? Multiply both sides by 2, and b equals 8. All right, so the homework assignment that's due on Monday, when you're working backwards, that's all I need to say. I don't need to necessarily see that, but if you give me that, I'm good to go. All right. Now, number 9, in a parallelogram. Well, it makes sense I draw myself a parallelogram. It says the base and the corresponding height are in the ratio of 5 to 2. And the area, they tell me, is 250. Find the lengths of the base and the corresponding height. All right, find the lengths of the base and the corresponding height. All right, so we throw an x there and an x there. Now we take 5x times 2x and set it equal to 250. 5 times 2, of course, gives me, lucky number, 10. X times x gives me x squared. How do I get rid of a multiplication by 10? So x squared equals 25. How do I undo the square? Square root of 25 is? Now, why is it not negative 5? If I plug it back in, what kind of dimensions do I get? Negative, so I don't need the negative. So x is 5. And then when I plug it back in, what's 5 times 5? 2 times 5. 25 times 10 is 200. So I'm good to go. All right.
Why'd you say it's negative?
Technically, when you solve algebraically that equation, x squared equals 25, you do the square root of both sides. Okay? You're going to walk in next year to Algebra 2, and you're going to be expected to know that it's a plus minus 5. But with regards to this class, if I put a negative back in, it gives me negative numbers. So it's an example of extraneous. Sorry, I went through that a little too quick. Good? All right. So if you would please work on 10 and 11. Please work on 10 and 11. Period B, Chapter 7 quiz. Let's see who's working away at it. Are you missing? Nope, all taking it. Woohoo! Yeah, Ryan, Hayden, Colin, Emma, and Ryan. 3, 7, 8. All right. So if you get a problem like number 10, where they're asking you to list all the possibilities. First off, 1/2 base times height equals 16. Base times height is 32. Always use 1 in the number itself. That's the easiest one to get. So 1 and 32. Does 2 also go into 32 since it's an even number? Yes, 16. Does 4 go into 32? Yes, 8. Now at that point you stop. The reason being is this. If you do the square root of 32, all right, it comes out to be about 5 point something. All right. That means at that point, if you go past that, you're just repeating yourself. Does that make sense? So in other words, 8 times 4 and 4 times 8 would be exactly the same. So you should never have to go past the square root of your number when you're listing them. All right. And then for number 11, how does 40 sound? Good. Just reiterates the fact that a triangle is half a rectangle. Since they're congruent and the area is 80, half of 80 would be 40. All right. All right, on the back, some triangles. All right, for number 15, who's not coming to the party? 12, 5, or 13? 13's not coming to the party. Why? Because 13 is a hypotenuse. And as great as hypotenuses are, do they make right angles with anything? No, so therefore we're going to do the other numbers. 1/2 5 times 12. Again, because multiplication is commutative, you can do any order you want. Half of 12 would be 6. 6 times 5 gives me 30 meters squared. And 16, who's not coming to the party? 3. Good, because it's an extension, not a side. So I'm doing 1/2 12 times 10. Myself, I would do half of 12 because that's 6, and multiplying by 10 is just down to 0, 60 centimeters squared. All right, on Monday, we will talk about converting between square units. All right, coordinate geometry. Starting with number 18. All right, so I plot me some points. -3, 1, -3, 4, 7, 1, 7, 4. Why am I in luck? What type of shape does that make? Rectangle. So now it's just counting. So from -3 over to 7 is how much? Rhymes with men. 10, or rhymes with women. And then from 1 up to 4 is how much? 3. Everybody understand where those numbers are coming from? All right, what's 10 times 3? So it's 30 units squared. For number 19, we have if you don't at first succeed, try triangle. -1, 1, -1, 6, 2, 6. Why am I again in luck? Right triangle, so the base and the height are dimensions. From 1 up to 6 means I'm elevating how much? 5. And from -1 to 2 means I'm going over how much? 3. Shuffling over. 5 times 3. But because it's a triangle, remember to what? Divide by. And you get 7.5 units squared. Good? All right, if we look at number 20, 2, 2, 5, 5, 5, 0, and 2, -3. All right. I'm half in luck. Why? Why am I half in luck? It's congruent. Okay, let's take a step back. I forgot. Unlike 6.7, you don't have to prove it with slope and all that. You should be able to look at it and realize that since that's parallel to that, and that's parallel to that, that's parallelogram. The half luck is because that is what type of line segment? Rhymes with vertical. Vertical. So if I'm going from 5, 0 to 5, 5, I'm going up 5. So the base can be 5. You good? Now I just need the height. All right, so now I'm going to look at the x-coordinates. The x-coordinate here is 2. The x-coordinate there is 5. How far is it from 2 over to 5? So the height would be 3. And so base times height would be 5 times 3, giving me 15 units squared. All right. You could, if you had to, and when you get in irregular shapes, you can do that as well. All right, you can do that as well. Something interesting on your phone? The same. Okay? And you can divide it into rectangles and triangles should the need arise. Talking about dividing into rectangles and triangles, we got 22 and 23 up top. All right, if we look at 22, we got a square to the left. What are the dimensions of the square? 15 and 15. What am I going to do to those? Multiply them together. I got 225 centimeters squared. All right. What are the dimensions of the triangle that give us area? 15 and 8. I'm going to do 1/2. 15 times 8. Half of 8 is 4. 4 times 15 is 60. What do I do with 225 and 60? Add them up, and I get 285 centimeters squared. All right, so when you're doing area, you can add them together. Why could you not add their individual perimeters up? Why could you not add their individual perimeters up? Because they share a what? Side. All right, any questions? All right, so you have homework up in Google Classroom. All right, 10.1 homework, week of March 1st to March 5th. All right, when we're looking at it, all right, for numbers 1 through 6, all I'm looking for is the numbers you multiply together. So in other words, in number 1, what 2 numbers are you going to multiply together? 3 and 14. So just write down 3 times 14 equals. All right, that's all you need. For 7 through 9, you're working backwards. I don't need to see you calculating the area. For example, in number 7, the base is 8, the height is 3. So 8 times 3 would be 24. I would just like to see that set equal to the other equation, which would be h times what? What is h perpendicular with? Rhymes with more. 4. So 24 equals 4h. 10 through 15, same idea, just looking to see what you plugged in. 16, just like the one we did today. 17, you just got to list them. All right. For 21 through 24, where it's coordinate geometry, if you just want to sketch them and put your area in, that's fine. All right. 25 through 27, individual areas. Everything else is pretty much self-explanatory. Do you have any questions? Those of you at home, do you have any questions? Okay, on Monday, virtual students, when you log on, just be a little patient because we got to rearrange seating because everybody's back on Monday. But we will eventually be all together on Monday. Okay? Have a great weekend. Be safe, everybody. See you on Monday. There we go. Bada bing, bada bing, bada bing. Well, we will talk about what exact means and all that good stuff.
Oh my goodness, go every day. That's gonna be like